Hey, y'all, today we're going to start talking about triangles, and specifically today we're going to be talking about the angles in triangles and how they interact with each other. And so the first thing we need to know always about triangles is what their interior angles add up to. So interior just means inside, and we always have three angles. There's one, there's another, there's a third. And whenever we add these angles, let's call them angle 1, 2, and 3. If we were to add all of these angles, so the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3, in any triangle, those angles are going to always add up to 180 degrees. And so what's nice about knowing that is if you know a couple of the angles, you can always find out the missing angle. So here we have two angles, 135 and 20, and we want to know what this missing one is. Well, we can add them all up. All three of those angles should add to 180. And then, much like we have recently, we have an equation to solve. And sometimes they'll be easier than others. I'm going to do 155 over here, which makes it negative. And so 180 minus 155 is 25. So our missing angle in this triangle is 25 degrees. The three angles in a triangle should always, always, always add up to 180 degrees. And I will write this here. There is never a time that we can build a triangle when their angles will not add up to 180. So if we have three angles and they don't add up to 180, we have not made a triangle. So there's our three angles. I know two of them. I can find the other one by adding them all together and then saying they should equal to 180. I'm going to move this 125 over here, and it's going to become negative, so I get 180 minus 125, which is 55. So our missing angle is 55 degrees. Of course, you know what we're going to do. We're going to throw some expressions in here that make this a little more complicated. But if you practice this way, where you actually show that we add up all three angles and they equal 180, then when we have something a little more complicated inside of our picture, we can just do the same process and maybe have a couple more steps algebraically until we get to the answer. So I want you to try this one on your own. Put your answer into the answer box that pops up, and then when you continue watching, I will have my solution. I'm not going to go over it, but I'll have the solution there. If you didn't get the right answer, please do ask one of us for help so that we can try and fix any mistakes before you get too far. If you did get the right answer, well done. Now you might have noticed that I mentioned something called an interior angle earlier in this lesson a couple minutes ago. And that's because we typically look at the inside of a triangle and those angles inside, all three of them. But we can also draw exterior angles at each vertex. So a triangle, again, has three angles. That means it has 1, 2, 3 vertices. And so we could draw angles if we extend the sides, and we could get 3 exterior angles that are related to the 3 interior angles. It's you might notice, but I'll make a note here, that at every interior angle, the exterior angle that's next to it that shares the vertex, they form a linear pair. So these two angles are always going to add to 180. So any interior angle is going to add to 180 with its exterior angle. They're supplementary, they're a linear pair, they add to 180. But the thing that you might not be able to see before I tell you is that if you take this exterior angle, so we have the exterior angle at vertex F, that angle is going to be equal to the interior angles at the other vertices. So our exterior angle is at F. So if we take the interior angles at G and H, if we add them together, it will be equal to that exterior angle. We call these angles, these interior angles that are not sharing the vertex with the exterior one, we call them remote interior angles. We call them remote interior angles because they're further away from that exterior angle. Sort of like being on a remote island. And so again, we have an equation to solve. I can move this 55 over here and it'll become negative, so I get 140 minus 55, which gives me 85 degrees. So I found that that interior angle I was missing was 85 degrees. So here we have this angle that is 38, that angle that's 14, it kind of tightly packed in there, so that might be hard to determine. And then we have the exterior angle right here at vertex D. And so this exterior angle at vertex D should be equal to the two angles inside at the other vertices. So angle E and angle F, if we add them together, they should be equal to the exterior angle at angle D. And so I can add these together and get my exterior angle to be 52 degrees. So again, we want you to give this one a try. Put your answer in the box that pops up. Then check your answer against the one that pops up that you see. If you didn't get it correct, please do ask one of us for help so that you don't go on and do a bunch more problems, making maybe the same mistake. So if you got 93, well done. If you didn't, please make sure you ask one of us for help before you move on so that we can see where a mistake has occurred. So we have 8 problems for you to do, and you will put your answer in the box. If you need help along the way, please do ask. Take your time on them. Use the examples we did in the lesson to help you. And again, as I always say, ask us for help if you need it.